Welcome to today's video on a brand new topic, which is C4 chemical changes. So we're jumping into some chemistry today and for the next few weeks, and we're going to be doing this topic called chemical changes. Today we're going to look at something called reactivity of metals, drawing on some of that key stage 3 knowledge you have. Then we're going to be moving on to looking at extraction of metals. Then we're going to look at something called oxidation and reduction, which we'll touch on today. Then we're going to move on and look at reactions, particularly those with acids, and then we're going to think about how they react with bases and create these salts, how we make soluble salts, and then we're going to finish off with something called electrolysis. So let's start. You're going to need a pen and paper because we're going to start off by doing a struggling to remember quiz. Pause the video at any point you like to try and do that answer, or you can wait till you've had all the questions and then click pause on the video. So question number 1, name a reactant of respiration. Question 2, what does soluble mean? Question 3, what type of bond forms between a metal and a non-metal? Question 4, what state is oxygen at room temperature? Question 5, what is the name for group 1 metals? Question 6, how could you dilute an acid? Question 7, what is a synapse? And question 8, how often on average are mature eggs released from the ovaries? So you're going to click pause now and you're going to complete those answers and try and find those answers in your brain. If you don't know, have a guess. Okay, you're going to now replay the video and we're going to go through those answers. So question number 1, name a reactant of respiration. You could have had oxygen or glucose. So both of these are chemicals which are needed for that reaction of respiration. Question 2 is, what does soluble mean? Well done, if you can remember, that means it's able to dissolve. Question 3, what type of bond would form between a metal and a non-metal? That would be an ionic bond. Question 4, what state is oxygen at room temperature? Oxygen is a gas. Question 5, what is the name for group 1 metals? They are called the alkali metals. We'll explore why they're called the alkali metals in these series of lessons. Question 6, how could you dilute an acid? So to dilute something, you make it less concentrated, and therefore a good way of doing that is by adding water. Question 7, recap from your last topic, what's a synapse? A synapse is the connection between two neurons. Question 8, how often on average are mature eggs released from the ovaries? On average, it occurs every 28 days. So compare all of these answers with the answers that you have got written down and see how well you have done out of 8. So today we're going to be looking at the reactivity of metals. So we're going to look at a context that we can see all the time. So here we've got an example of a metal which has reacted to form a different kind of colour. We can see that in more detail if we look at this rusting bike. So we can see here that this reaction is actually the process of rusting. And if we zoom in a little bit further, we can have a look at those chains. We can see that they've got a different colour and perhaps they don't work as well as they used to. So what is happening here? This is a process called rusting. And actually, if we examine the Spanish word verb to rust, it's oxidar. So have a think about what you think that metal might be reacting with in order to form that rust. So well done if you picked up that perhaps it's oxygen, you would be correct. So here we've got steel, which is an alloy of iron. That means it's got some iron in it, and the iron is reacting with the oxygen, and earlier you identified that oxygen is a gas, it's in the air, and it's creating this rust. So this is a really slow process where the iron is reacting with the oxygen in the air to form something called iron oxide. We can speed up this process though by applying some energy. So you can see here that when we burn iron, it starts to form that iron oxide, and that's exactly what is happening here. So you're now going to watch a video showing that reaction sped up where iron is reacting with oxygen in the air. we've looked at one example of a metal reacting with oxygen, but most metals will react with oxygen. So an example we can see over here is magnesium. When magnesium is burnt with the oxygen and reacts with that oxygen in the air really quickly, it creates this bright flame. So you might have seen that with a sparkler. When a metal reacts with oxygen, we call the product a metal oxide. So we have this general equation, which is metal plus oxygen, arrow metal oxide. We call this an oxidation reaction, and that's because oxygen has been gained. So what I want you to do is copy down that general equation in the orange box. We've also got this other word called reduction. So we know that oxidation is the addition of oxygen, or we've got another type of reaction, a reduction, which is where we remove the oxygen from a substance, and that takes place in a reaction. More on that later. So we are now trying to have a go at retrieving some of that information that we've just gone through. So what I would like you to do now is read through this question that you can see, and I want you to pause the video and have a go at answering the questions. Okay, so hopefully you've had a go at those. We're going to go through them together. So it's telling us that in the experiment that calcium is being burnt and it's reacting with oxygen. Our general equation is that a metal reacts with oxygen to form a metal oxide. So in this case, our metal is calcium. So I'm going to write calcium in this gap here. And I know that it's reacting with oxygen, so that's going to be the other reactant. Now I know that a metal oxide is formed, so in this case my metal oxide is going to be called calcium oxide. So well done if you got that word equation correct. Part 2, in this reaction oxygen is gained. What type of reaction is this called? We know that if oxygen is gained, it is called an oxidation reaction. Part 3, if oxygen is removed, what type of reaction is this? In this case we call it a reduction reaction. So what did you get out of 3? We're now going to compare the different reactivity of different metals, and to do that we need to recall some information from a previous topic. So you're going to do a bit of brain pain. You're going to get some brain pain from doing this by recalling it, and you're going to try and draw a dot and cross diagram to show the reaction between sodium and chlorine. So pause the video now and have a go at doing a dot and cross diagram to do that. If you can't, have a go, but if you can't, that's fine. You can hit play again and see me do it. Okay, so I'm now going to model how you would do this, how you would work out the dot and cross diagram from the symbols of sodium and chlorine. So I'm going to start off with sodium and I'm going to think about how many electrons it's got. So I can see here that the bottom number is 11, and that infers that there are 11 protons. And from that I would know that there are also 11 electrons. I know that 2 electrons are allowed in the first shell. I know that 8 would be allowed in the next shell. I've used up 10, and that means I would only have 1 more left. So that means this is the electron configuration for sodium. So what that means is that there's 1 electron in its outer shell. It's in group 1, it's an alkali metal, and therefore it's got 1 electron in its outer shell. So I'm going to draw that by representing just the outer shell, and I'm going to draw that with a dot there. So that's showing that it has an electron in its outer shell. Chlorine then, it's got 17 electrons. I know that because that's the bottom number, it's the number of protons, which is the same as the number of electrons in an atom. So they are allowed to have 2 in the first shell, there would be 8 in the next shell. I've used up 10, I'm allowed up to 8 in the next one, but I've only got 7 left, and therefore that's the electron configuration for chlorine. I can see that there's 7 electrons in its outer shell. That's in group 7, so that makes sense. So I know that when sodium reacts with chlorine, chlorine is going to start off with 7 electrons. So I'm going to draw it as crosses. Okay, so when they react, they come together to form an ionic compound. Remember, an ionic bond is between a metal, which is sodium, and a non-metal, in this case chlorine. So what does that look like then? So my sodium then is going to remain as it is. Now it had an electron in its outer shell, but actually it's lost this electron now. it's transferred that electron to chlorine, so that underneath that it's got a full outer shell, because that's an atom's dream, is to have a full outer shell. So that sodium now, because it's lost its electron, it's now changed its charge. An electron has a negative charge, so if you lose something that's negative, it becomes a positive ion, and I can represent that with these funny brackets, and I can put a positive charge up there. The chlorine hasn't lost any electrons, it's still got those 7 in its outer shell, but it's also gained the electron from sodium, and therefore it's going to have a dot to represent that that has come from sodium. Now the chlorine has gained an electron. Electrons have a negative charge, so if it's gained a negative charge, that means overall its charge is negative. So this is an ionic compound in which we have formed a metal, which is a positive ion, and a non-metal, which is the negative ion. So why is this important? Why have I asked you to think about a dot and cross diagram? Well, the reason is because what I want you to try and remember is that the metal forms a positive ion, and that's because it loses electrons, and that means it's reactive. It's able to transfer electrons, or 1 electron. So here's an example of something you've seen before where we've got lithium reacting with water. So lithium, again, a bit like sodium, is a group 1 metal, and therefore it's really reactive. It really wants to lose its electron and become a positive ion. When it does that, it reacts with the water and it creates this gas. And we can see another example of a group 1 metal. We can see potassium here reacting with the water. And what I can see is 2 different strengths of reaction. I can see that potassium has got a bigger reaction. It's more violent compared to lithium. And therefore we know that different metals have different reactivity, and that's what we're going to explore in this next section. Now, when that lithium or any of those group 1 metals reacts with the water, they produce something called lithium hydroxide, and they produce a gas which is hydrogen. And what I want you to see here is that lithium has rearranged itself, and now it's with a product, it's in lithium hydroxide, and therefore it's become a positive metal ion. Here's another example of where a metal has reacted to form a positive metal ion. And we can see here that potassium has in fact reacted with an acid, and it's created something called potassium chloride. And I can see that that has rearranged itself, it's made a product, and it's now part of that potassium chloride, and it's become a positive metal ion. So you're going to watch a video now to see that reaction take place between potassium and hydrochloric acid.
Here's the reaction of potassium and concentrated hydrochloric acid. This is 12 molar hydrochloric acid and potassium metal. On the counter, the lab counter, I have the potassium metal, barely visible at the bottom of your screen. And to the beaker, I'm going to add 5 milliliters of 12 molar hydrochloric acid. And I'm going to cut as small of a piece of potassium metal as I can. It's a very, very soft metal. You can see the oxide layer is forming again on the potassium metal. It's that reactive. It reacted right away with the air. Okay, I'm going to add it to the concentrated hydrochloric acid. Wicked cool.
So what we've learnt so far is that when metals react, they form positive metal ions, and the reactivity of a metal is dependent on its tendency to form positive ions. So different metals are more likely or less likely to form these positive metal ions compared to others. And we can summarise that in this table that you can see here. This is the reactivity series. At the top we have the most reactive metals, and at the bottom we have the least reactive metals. Notice as well that we've got carbon and hydrogen, which are non-metals, which typically get included in the reactivity series. More on this later. So what you need to know is you need to know about the reactions with these metals with cold water and describe those reactions, and you should be able to describe the reactions with those metals with dilute acids. So have a look at that. What I would like you to do is I'd like you to pause the video and write down the order of metals going from most reactive at the top to least reactive, so that you've got it in your notes so you can apply it to some questions in a minute. Okay, so you're now going to have a go at doing some questions again. What I'd like you to do, please, is click pause and have a go at doing A, B and C. Okay, so welcome back. We're going to have a go at doing those questions together. So the first question was to describe the reaction of potassium with water. So looking at that table before and having tried to remember what happens and looking at that animation I showed you earlier, the things that we need to write for this is that it's a violent reaction and that a gas is produced. Part B, describe the reaction of potassium with dilute acid. So you saw what happened when potassium reacted with that acid in that video earlier on. So again, we would write something like this: there was a violent reaction and a gas was produced. Part C, the reactivity of potassium is related to its tendency to form what? And remember that we always talk about the formation of positive metal ions. So give yourself a score out of 3. So one of the things that you should be able to do is put the metals in a series based on a reaction, based on some data from a reaction. So here we can see that a student was investigating the reactivity of 3 different metals. They used this method. They placed 1 gram of metal powder in a test tube. They added 10 centimetre cubed of hydrochloric acid. They waited 1 minute and then recorded the volume of gas produced, and they then repeated using other metals. So I can see that they've looked at zinc, copper and magnesium, and we can see the volume of gas being produced. Now I'm going to put my scientific hat on and I'm going to think about which one must be the most reactive. If something's really reactive, it's going to produce lots of the gas in this case. So the thing that is the most reactive is the magnesium, because it's produced the biggest volume of gas. So therefore I'm going to put magnesium at the top of this question, because it says use the results shown in the table to place these metals in order of reactivity. So magnesium is going to go at the top of my list. I'm going to have a look at what I think is the least reactive. So which one has produced the least amount of gas? And that is copper. So I'm going to put copper at the bottom. What's in between that? Well, in this case, it's zinc. And that is how I would get those marks for this particular question. Okay, your turn now. So click pause and have a go at doing a very similar question to the one we just did together. Okay, so we're going to go through the answers together. So exactly the same question, but this time different metals and different volumes of gas which have been produced. So the most reactive was the one that produced the most amount of gas, and therefore that was sodium. The least reactive this time was iron, and calcium was in between. So have a look at that. What did you manage to achieve? Did you manage to get it? Okay, very similar question again, but this time we've got an unknown metal. So when you write your reactivity series in part B, just write unknown. Part C asks you to suggest what that unknown metal could be. So I'm going to put a clue there. Hopefully you wrote down the list that you need to recall, which is that reactivity series, and see if you can work out what you think the unknown would be. Okay, so we're going to go through the answers to that. So the most reactive metal this time was lithium, so I'm going to write lithium at the top. The least reactive was magnesium, and I know that the unknown was in between. So that is worth 1 mark, writing it in that order. Part C was suggesting what the unknown metal could be. I'm going to refer to the reactivity series here, and I'm going to identify where lithium is. So that's here, and I identify where magnesium, which is here. So which metal is in between them? In this case, it's calcium, and therefore the unknown metal I'm going to suggest is calcium, and that's worth 1 mark. So you've now applied ideas about the reactivity series, which is the metals in an order of reactivity. And we know that reactivity of metals is to do with the tendency to form positive metal ions. We're now going to look at something called displacement, where a more reactive metal displaces a less reactive metal. We've got an analogy here. We can see that Joe, who is in green, comes along and he is more reactive. He's representing a more reactive metal. And what's happening is that he is shoving out Frank, who is least reactive or less reactive, and him and Mary, Joe and Mary, are together on the product side. So they're representing a compound now, and Frank has been shoved out the way and he's now on his own. So this is a displacement reaction where a more reactive person here or metal displaces a less reactive metal or person. So this is what it actually looks like in chemistry. That was just an analogy where we've got magnesium and iron. So iron chloride is currently our compound, magnesium is currently on its own. If I look at the reactivity series, I can see that magnesium is above iron, it's more reactive, and therefore it's going to displace the iron from its compound. And therefore you're going to end up with something called magnesium chloride, and that's our compound now, and iron on its own. So this is a displacement reaction. So what you're going to do now is you're going to use the reactivity series to predict if each mixture will react and complete the word equation. So for example, if I have magnesium reacting with iron chloride, like we saw on that last slide, the magnesium is more reactive than iron, and therefore I'm going to form magnesium chloride. It's stealing that chloride, and the iron has been displaced, so iron will end up on its own. So what I would like you to do is click pause and have a go at doing A to F and see what you can do. Okay, so we're now going to have a go at doing those together. Remember that some of them, there might not have been a reaction at all, okay, and some of them would have formed new products. So let's have a look. So magnesium and zinc chloride. So I'm going to look at my reactivity series. I can see that magnesium is more reactive than zinc, and therefore we're going to get a displacement reaction. And therefore we're going to form magnesium chloride, and that's going to displace the zinc, and therefore zinc is going to be left on its own. Okay, part B, copper and zinc oxide. So copper is below zinc in the reactivity series, and therefore we're going to get no reaction taking place here. There's no displacement. So no reaction takes place because that oxide is already with the more reactive metal. So no reaction. Part C, copper and gold nitrate. So I can see that copper is above gold on the reactivity series, and therefore we are going to get a displacement. So the products are going to be copper nitrate and gold. Okay, part D, magnesium and copper sulfate. So I can see that magnesium is higher than copper on the reactivity series, and therefore we are going to get a displacement reaction. So we're going to get magnesium sulfate and copper. Okay, gold and copper sulfate. Now I can see that gold is least or less reactive than copper, and therefore we're going to get no displacement reaction. So therefore, when you react these together, they will just continue to be a mixture and there will be no reaction. Last one, sodium and potassium oxide. I can see the potassium is actually right at the top of our reactivity series here, and therefore it's the most reactive, and therefore we're going to get no reaction. Oxide is already with the most reactive thing, and therefore we have no reaction take place. So we had 6 questions there. Give yourself a score out of 6. Okay, now we've done that practice together, you're going to have a go at doing this exam question. So click pause and have a go at doing this exam question. Okay, so now we're going to go through the answers together. So the first question is asking us about completing a word equation. We need to know about the reaction first. So beryllium can be extracted from beryllium chloride. Beryllium chloride is heated with potassium. Potassium is more reactive than beryllium. Complete the word equation for this reaction. So we've got beryllium chloride. It's reacting with potassium, and therefore potassium is going to be the other reactant. Now, we know that potassium is more reactive and therefore it's going to steal that chloride. So one of the products will be potassium chlorides. Because there's been a displacement reaction take place, we know that beryllium will be left on its own as one of the products. That's worth 2 marks, 1 mark for your reactant side and 1 mark for your product side. Okay, part E, explain why beryllium is produced when potassium is heated with beryllium chloride. You should refer to reactivity in your answer. So this is worth 2 marks. Here's what you need to write. Potassium is more reactive, so it will displace beryllium. So have a look at that, compare your answer. Here's another exam question that you're going to have a go at doing. So what I'd like you to do, please, is read through that. This one's about temperature change. So part I is to place the metals in order of reactivity. Part 3, ignoring part 2, use the results to work out which metal is the most reactive. Then part 4, explain why there is no temperature change when silver metal was added to the copper sulfate solution. So what I want you to do is pause the video and have a go at completing that now. Okay, so we're going to go through the answers together for this. So you're going to start off by looking at trying to put these in an order of reactivity. So if there's a bigger increase in temperature, that means it's more reactive. So therefore the most reactive metal would be magnesium. So I'm going to just put some numbers next to them. The next most reactive metal was cobalt with 4.5. After that it was nickel. After that it was tin. And then after that, we've got 2 which are tied. So we're just going to give them the same score. Okay, we can see that there's no temperature increase and therefore no reaction has taken place. Okay, part 3, use the results to work out which metal is the most reactive and give a reason for your answer. So the most reactive was magnesium because there's a biggest temperature change. Nice, easy marks. Part 4, explain why there was no temperature change when silver metal was added to the copper sulfate solution. So 2 marks, it does not react, that would give you 1 mark, because silver not more reactive than copper, or silver is below copper in the reactivity series, and therefore, a bit like we showed you earlier on, no reaction had taken place. So this is the end of this video. You've learnt today lots of things about the reactivity of metals. We started off by thinking about a process that we all know, which is rusting, which you can see here, and we can see that that was when iron was reacting with oxygen in the air. We then thought about that as a sped up process, and that happens when we burn iron and it forms iron oxide, and we learnt that general equation, which is metal plus oxygen goes to a metal oxide. We then thought about the differences in the tendency of metals to form positive metal ions, and we looked at that in terms of the reactivity series, that order of metals. We looked at the reactions of these metals with water and with acids, and we summarised that using this table over here. We then looked at displacement reactions, and that's dependent on the reactivity of our metals. So we've looked at lots of things today. Please join me next lesson where we're going to look at the extraction of metals based on the idea of the reactivity series.